Chapter 6 packet. Chock full of goodness. We're looking at not 1, not 2, but 11 pages of fun. Well, let's get started. This first page only has one problem. A graph below shows how the cost of gasoline changes over 1 month. According to the graph, the cost of gasoline sometimes, never, or always decreases. Well, right now the gas is a price, and then it goes all of a sudden higher. Now, if you go to the store, if you go to, the gas store or the gas station, you might see that maybe gas prices are $2.99, and then all of a sudden it's $3.01. Thanks, Obama. Well, what's happening is it changes all of a sudden. So it's this price, and then boom, it changes. This price, boom, this changes, this price. So it goes higher, and then lower, and then higher, and then lower, and higher. So it decreases. Since I said the word lower twice, it decreases sometimes. And in this case, this is where it decreases. From here to here is a decrease, and from here to here is a decrease. Perfect arrow by me. Well, speaking of perfect, page 1 is done. That's a perfect rhyme. I have to make a mapping diagram. Now, I'm just going to take these points and pretend this isn't multiple choice. So here are my points. I have -3, -6, -1, -6, 5, -6, and 8, -6. Thankfully, it looks like the left side is already done for us. So domain, range, or input, output, however you want to word it. If I have -3, so again, this is my domain, -3, -1, 5, and 8 already in order. -3, -1, 5, and 8. My range is -6, -6, -6, and -6. So this is really easy. -6. -3 goes to -6. And -1 goes to -6, and 5 goes to -6, and 8 goes to -6. So you happen, and you happen, and you happen, and you happen. Now what I have to figure out if this is a function or not. Every x value has its own y value. The x values don't split off and go to another thing. So if I have every x going to its own thing, this is a function. Where it won't be a function is if that -3 were to go here and here. That doesn't happen, so this is a function. So what do we have here? It is a function, so let's cross out the ones that say not a function. So you're not an option, and you're not an option. The domain is -3, 1, 5, 8. Not you, you. Or as Soldier Boy would say, you, because of the song. Hey man, didn't we just finish chapter 4 where we had to do all this graphing? Well, we did. And we're doing some more. Y is already by itself, so that makes life easy. -3x minus 3. This tells me that the slope is -3/1, so I'll write that out down here. I'm approaching this packet as if I don't have multiple choice. So the slope is -3/1. When y is all by itself, the slope is the number in front of x. The y-intercept is the number floating around by itself. So the y-intercept is also -3. I'm not going to write out -3/1. That's wacky. If I wanted to draw a quick picture, right, my y-intercept is -3, so I put a dot right there. I go up 1, 2, 3 over 1, put a dot there. Go up 1, 2, 3 over 1, put a dot right there. And I would have a line that looks like that. Which means not you, and not you. You go through -3, you go through +3. So not you, you. A. The answer is A. Forget about it. Slope, rise over run. Change in the y values over the change in the x values. So let me see where my dots are. Oh, I don't have any dots. So put dots that make sense. I could put dots here and here. I could put one here. I could put one here. I could put one there. But these are the ones that I chose. This is a negative slope, so my answer is negative. And I go up 1 over 1, 2. There you have it. Nothing new. Find the value of y for the given value of x. Here's y. Y equals 8x plus 9. But you know what? X is 9 over 2. So instead of x, I'm going to substitute with the parentheses 9 over 2 plus 9. 8 times 9 over 2 is going to be 36. Look at me doing quick math. Quick way of doing fractions. If you're multiplying a whole number, divide that number. 8 divided by 2 is 4, then multiply to the top, times 9. So 4 times 9 is 36, and 36 plus 9 is 45. Fun fact, that's the president's signature. What's this? Ugh. All right, so I could do this using LinReg, but I don't have a calculator. I mean, I have this pencil and I have this stick, but that's not going to help me. So this is what I have to do. I'm going to remind myself that the slope is rise over run. If I'm writing a linear function, linear functions look like y equals a slope x plus the y-intercept. Okay, so the slope is rise over run, and the y-intercept is where my line goes through the y-axis. Well, actually, this is really easy. If it goes through 0, 0, my y-intercept is 0. So what I have so far is y equals, I don't know, x plus 0. I have to find the I don't know, and the I don't know is the slope. So the slope is the rise over run, also known as the change in y over the change in x. So let's find out the change of y and the change of x. X seems to go at plus 7, plus 7, plus 7, and y seems to be negative 2, negative 2, negative 2. So the y's are always changing by negative 2, and the x's are always changing by positive 7. So the rise is going to be the y, rise, y's, see that? Negative 2 over the change in x, which is positive 7. So my slope is negative 2 over 7. So if I put all this together, okay, I know it's a mess. I get y equals negative 2 over 7x plus nothing, or y equals negative 2 over 7x. Now, normally we would do LinReg, but I don't have a calculator with me, so I ain't gonna do it. There you have it, kids. Life without calculators. It is a terrible life indeed. Actually, it's fine. More functions, gross. Let me get my calculator. Psych, yeet, I don't have one. So let's again do it without a calculator. My equation is y equals mx plus b.
Amir Harrison to the main office. Amir Harrison to the main office.
Y equals mx plus b, where m is my slope and b is my y-intercept. Okay, so let's find the slope. My change in x is add 3, add 3, add 3. My change in y is add 7, add 7, add 7. Okay, slope is rise over run, so y's over x. So y equals rise over run, 7 over 3, x plus my y-intercept. My y-intercept is where my line crosses the y-axis. If I were to graph these points, I would have negative 6, negative 19, which is way down there. Negative 3, negative 12, which is way down there. 0, negative 5, which is there. All right, I keep getting buzzed. The thing at my school keeps going bing, so let's try that one more time. My y-intercept would be 0, negative 5, so that would mean that my y-intercept is negative 5. So I would put a negative 5 there, and to clean it up, I would say y equals 7 over 3x minus 5. Hey, perfect. Y equals 7 over 3x minus 5. Cool, great, easy. 8. More equations. Looks like I have a slope of, I really can't tell because everything's in the middle, but what I can do is these go up by 2. So my slope is rise 2, 4, 6. These go by 2 also. So my run is 2, 4, 6, 8, 10. 6 over 10 simplifies to 3 over 5. So my slope is 3 over 5. My y-intercept is the 0.4. So if I put it all together, y equals mx plus b, y equals 3 over 5x plus 4. I can do LinReg, but that's not fun. Speaking of fun, which equation represents the function shown in the input-output table below. I'm going to do this backwards. You ready? I'm actually going to plug values in to see if it works super quick in my head. For example, this page is an absolute nightmare because I keep getting interruptions. The announcement thing here keeps going beep, beep. One more time. I'm going to finish this page and I'm going to be done for this page for the day. All right, what I'm going to do is I'm going to plug in these numbers for x and see if I get these numbers for y. If I do, I have my answer. If I don't, I don't. For example, if I plug in 1 into the first one, I can say 10 times, and the thing beeped again. If I plug in 1, I should get 10. 10 times 1 is 10. Oh, good. If I get 2 or plug in 2, I should get 17. 10 times 2 is not 17, so it's not you. Let's try B. 7 times 1 is 7 plus 3 is 10, so that works. 7 times 2 is 14 plus 3 is 17, so that works. 7 times 3 is 31 plus 3 is 24, so that works. And 7 times 4 is 28 plus 3, it's that one. Now, if I wanted to do this super quick, without a calculator, I would do the whole thing that I did the last couple times. Y is mx plus b, okay? It's y is the change in y's over the change in x. So this is plus 1, plus 1, plus 1. This is plus 7, plus 7, plus 7. So my slope is y equals 7x. And I already hit my answer because none of these have 7 for a slope. If I wanted to find my y-intercept, I need to find out when x is 0. And so if I go in reverse, if it's adding 7 moving to the right, it would be subtracting 7 moving from the left. So that's where my 3 comes from. Oh, that was great. All right, done the page finally. It took 1 billion years, or at least 5 minutes. Page 6. New day, new outfit. List the ordered pairs shown in the mapping diagram. These are easy. This is going to take a minute. 7 goes to 5, which makes you wrong, which makes you wrong, which makes you right, and makes you wrong. Well, okay. Basically, you get the points 7, 5, 9, 6, 11, 7, 13, 8. If I were to go down here and pretend like I don't see these options, watch, you can't see them. I would be able to say that these points are 7 because the input, the domain is an x value, and that goes to 20. And 11 also goes to 20. And 15, which is an x value in the input, goes to that y value 25. And 19 goes to 25. And so that's going to end up being B. Nope, that's going to end up being D. Yeesh. Cool. That's a function. That's a function. Both functions, because every x value goes to its own y value. You don't see them split up into an opposite direction. Dope. Previously, on the last page, we talked about what makes something a function. Well, a function is when every x value has its own y value, okay? If an x value on the left side on the input repeats, which means if you see that process happening, like if I have an A go to a B and a C, that's like saying I'm going to put $1 in a soda machine, hit a button, and get a water and a juice at the same time. And that's not supposed to happen, gents. That's not a functioning soda machine. I wanted soda, gosh darn it. Sorry. So you're not a function because -3 goes to 3 different things. It's like firing an arrow called -3 and it hits 3 different targets. You can't do that, so that's a no. Let's look at B. 1 is good, 5 is good, but 9 goes to 2 different things, so that's a no. Let me see. Oh, I thought we had one. 9 here is a problem because 9 goes to 2 different things. That's a no. And of course, the last one we check where everything goes to its own thing, that's my function. It doesn't matter that 15 and 13 go to the same thing. Again, it's like if I had an arrow and my arrow is 5 and my other arrow is 13 and I shoot that arrow, those arrows, if they both hit the same target, that's good. It's fine. As long as that arrow doesn't split like that guy would. We don't like the splits, unless they're banana. Oh, cool, another one. All right, so we could do LinReg, but I won't. What I'm going to do is, same as I've been, I'm going to see if I can figure out the slope. And again, I have y equals mx plus b, and the slope seems to be, or the slope is rise over run. I know I've been repeating myself, but you know what? Math is repetition. And the rise is the change in the y values over the change in the x's. So let's see what my x's are. That's +3. That's +3. That's +3. So my slope, so far, I know I'm going everywhere, but that's what I do. The x values are 3. My output is +30. +30, +30. So positive and positive, 30 over 3 makes 10. So my slope is 10. Sorry, my slope is 10. Okay, again, I had 30 on the y's, 30 over 3 on the x's. 30 over 3 is 10. My slope is 10, which means if I were to take that 10 and find an equation, so far what I have is y equals 10x. In order to find my y-intercept, I have to find out when my line hits the 0 part of the x-axis. So, trying to think the best way to do this without overcomplicating things. I think the best thing to do is, here's a trick that I may or may not have taught in class. I'm going to put plus b here. This is what I have so far. Okay, this is what a lot of people do, and I haven't taught it yet, and I haven't done it in this packet yet, but I'm going to show you how to do it. This is what I have so far. I don't know what b is, but I do know that m is 10, and I have a bunch of x values over here, and I have a bunch of y values over here. So I'm going to pick an x and a y value. I'm going to plug that into that equation there and find my b. So if I were to look at that point and plug that point in here, my y value is 10. My x value is 1 plus b. 10 equals 10 times 1, which is 10 plus b. Subtract 10, subtract 10. That goes away too. B equals 0. So when I put it all together in this huge mess of a problem, y equals 10x plus 0, or just y equals 10x. Or you could just do LinReg. Or you could just pick an equation, plug these in, see which one works for all of them. Lots of options. The choice is up to you. Okay, page 8. New place, new lighting, new clothes. This is the wackiest video I've ever made. Which function does the graph represent? Well, we have ourselves a linear function. Y equals mx plus b will never go away, ever in a million years it seems. That's my slope. That's my y-intercept. My y-intercept is 0, so I can write out y equals something x plus 0, so I don't need that plus 0 to be written out. My slope, everything goes by 1, seems to be up 1. I need another dot, don't I? How about that one? Up 1 over 2, which means my slope is a half. Now look at the options. I don't have y equals a half x written out that way. But I do have 0.5, and last time I checked, 0.5 is a half. It's certainly not the others, that's for true. All right, describe. Describe the relationship between the two quantities. Looks like we have distance from home. These are miles, and this is time. This is when everything begins. So as time goes on, I'm driving further away from home, and then as time goes on, I'm the same distance away from home. So this is like, what this means is I'm driving away from home, and then I'm stopped. So let's see what we have. Distance from home increases at a constant rate, then stays the same. That's true. The distance from home increases over time at a decreasing rate. That doesn't make sense. The distance from home stays the same. That doesn't make sense. The distance from home is constant at first and then increases steadily as time passes. Nope. So it's A. I don't like the way it's worded, but can't help what's printed out. All right. Last one on the page. Find the value of y for the given value of x. Y equals x plus 3. And by the way, x is 8. So I could just write out y equals 8 plus 3. And last time I checked, 8 plus 3 is 11. Cool. 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 All right, page 9, almost done. The table shows the cost y in dollars for X theater tickets. Find the missing y value that makes the table represent a linear function. So we have a chart, another chart, and then a missing thing. There's so many ways that you can go about this. I don't know. I guess you could try to find the number in the middle. And the way that you could do that is you could just add these two, divide by 2, and that gets you the number in the middle, the average. I think what I'm going to do is I'm going to use LinReg. I haven't done LinReg yet, so let's do LinReg. Why not? Again, there's many ways that you could do this. This is not the only way that you could do it. This is just another way that you could do it. So LinReg in this case would be if I were to hit Stat, Edit, and start plugging in what I know. I have a 2 and a 26, so I'm going to enter 2, and I'm going to enter 26. I have a 6 and a 78, so 6, enter, 78, enter. And if you're like, well, what about that 4? Well, I don't know what that 4 is. That's kind of the point. So if I finish LinReg, second mode, Stat, Calc, LinReg, enter. I have the equation y equals ax plus b, or y equals 13x. So, if my equation is y equals 13x, then what I have is, if x is tickets and I need 4, why don't I just plug in 4? Y equals 13 times 4. 13 times 4 is 52. So y in this case is 52. And that's going to be our answer, $52, I guess, because it says cost. But, yeah, kind of weird. That's just the way that I did it. Again, it's all patterns. So if you're like, I could do that in a much easier way, then do it in a much easier way. For me, this is just an option, and we haven't done LinReg yet on this packet. I can do this without LinReg by finding the slope between these points and using the slope formula, but time is money, so I'm not going to do that. Not now. Gloria makes and sells hand-make greeting cards. Cool. The scatter plot shows the number of cards she made over a 10-hour period. Find the equation of a trend line that uses it to predict the number of cards Gloria can make in 12 hours. Well, of course, I just said that we haven't done LinReg, and guess what we're about to do? LinReg. Now, this is one of those things where my answer here and the answer in the back may not exactly match up, but I'm going to do the whole thing. It might take about 3 or 4 minutes. I'm going to do the whole thing using LinReg. Okay, I will show you that way of doing it, and I will show you a lazy way of doing it that will also work. So let's split our notes up into the LinReg and the lazy. I've heard of the young and the restless, but the LinReg and the lazy, that's not that at all. So this is LinReg. LinReg, there it is I take all of these points and plug them into LinReg. So I'm going to clear my calculator by hitting these buttons. Second plus 7, 1, 2, clear. And I'm going to start plugging all of these points in. Now, what each point is completely based off of what I see. It does not mean that my point is exactly, what it is. So if I look in the back of the book, my answer might be slightly different, but it's asking us to find an equation of a line and use it to predict the number of cards Glory can make in 12 hours. I'm not going to get anything exact, but I should still get a good answer for that. So, stat, edit, and away we go. First point looks like 1, 5. 1, enter. 5, enter. 2, we'll say 7. 2, enter. 7, enter. 3 looks like we'll say 13. 3, enter. 13, enter. 4 looks like 14. 4, enter. 14, enter. 5, 20. 5, enter. 20, enter. What else? 6, 22. 6, enter. 22, enter. 7, 26. 8, 31. We'll do 8, 31. 9, 34. Super exciting. All these dots. One more. 10, 41. All right. Done? Nope. Let's hit stat, calc, LinReg, enter. So there's my equation. Y equals 3.884, blah, 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 blah. And B is negative 0.06. So let's do this. I have to round. I'm going to round. Y equals AX plus B. I'm going to put 3.9. I probably could do 4 and it wouldn't be the end of the world. Now look. Minus 0.06. In reality, I should probably put, you know what, I'm going to do it. Minus 0.1. A lot of you might be like, Mr. Perich, couldn't you just do 4 and nothing? I could, but, I'm a math teacher, and this is kind of what I do. So that's my equation. Find the equation of a trend line, and use it to predict the number of cards Gloria can make in 12 hours. All right, so this is what I do. There's my equation. If I'm going to predict how many she can make in 12 hours, I'm going to use that equation and plug in 12. So 3.9. Instead of X, I'm going to plug in 12. Minus 0.1. Probably going to give us a decimal. And there it is. So if my job is to predict how many, I'm going to say 47, because I got 46.7, 47 cards. Now that was the LinReg way, which was like 3 or 4 minutes long. Here's another option that you can do, and it's just done by looking at the graph and finding the slope and the Y-intercept normally. If I were to take a straight edge, which I don't have, it looks like my line basically goes right through there. Ugh, awful. And so it looks like, based off of the line that I drew, it looks like if I were to make a prediction, I go up 4 over 1, up 4 over 1. And if you're like, I don't understand where you get that, then pick 2 obvious points and use that as your slope. But I'm going to go up 4 over 1, starting at 0, 0. Now, the reason why I'm starting at 0, 0 and not anywhere else is if in real life, if she's making greeting cards and you're looking at hours and time, you're not going to make any cards when you work 0 hours. So it's got to be 0. So I'm going to put Y equals 4X, and that's it. 12 hours is going to be Y equals 4 times 12. And in this problem, I get 48 cards. So we're making a prediction. If you're like, well, those are 2 different answers, sir. Shouldn't you get the same answer? No, not if I'm making a prediction. Excuse me, but do you know any psychic people who are always right? Okay, so that's that. Use the graph or table to write a linear function. Well, this is going to be a whole lot easier because all I have to do is draw that line through there. Y equals mx plus b. M is the slope, b is the y-intercept. My slope is up 1, 2 over 1, so y equals 2 over 1x, or 2x, and my y-intercept is negative 3. Whoo! Not easy. Easy. Almost done. All right, second to last page. The directions on the previous page said to make a linear function. So I'm not going to use a calculator. LinReg will definitely work, but I'm not going to do that. Remember, for the 50,000th time, if you don't have this memorized by now, you should. That's my slope, and that's my y-intercept. Slope is rise over run. The change in y over the change in x. The change in x is plus 1, plus 1, plus 1. The change in y is negative 4, or positive 4, positive 4, positive 4. So the change in y is 4, the change in x is 1, so my slope is 4 over 1, or just 4. X. My y-intercept exists when x is 0. Oh look, x is 0 and y is 0, so plus 0 is that, and that's that. Remember, if it's linear, it follows a pattern, and it's the same pattern throughout. Plus 1, plus 1, plus 1, plus 4, plus 4, plus 4. If that pattern changes, then I have to be able to do y divided by x to see if, that changes too. These are the easy ones. Linear or nonlinear. Is that a straight line? No, then it's nonlinear. It's linear. Just joking, laughed the lobster. Yeah, that's a line. I guess I was just, speaking of psychic from the last page, I was doing this. That's not a straight line. Oh no, but there's no graph here. Well, that pattern I talked about, plus 3, plus 3, plus 3. So there's a pattern, plus 3, plus 3, plus 3. So every time I do y over x, y over x, y over x, I get 1. And since these never change, this is obviously linear. You couldn't get much easier than that. All right, one more page to go. And here we are. Is it linear or is it not linear? Well, let's find the pattern. Plus 4, plus 4, plus 4, minus 7. Oh no, minus 14. Oh no, my pattern changed. Negative 7 over 4 is not the same as negative 14 over 4. Since it changed, it's non-linear. Graph the function. Well, it would be nice if someone would have given me a coordinate plane. So I'm going to make my own. See, when life hands you lemons, you make lemonade. Lemonade, Beyonce. Alright, so that's just the picture that I drew to start out. Okay. Go up 1, 2, 3. Boop. Rise 1, 2, 3, 1, 2, run 2, boop. Rise or lower 1, 2, 3, run 2, boop. Down 1, 2, 3, over 2, boop, boop. And ladies and gentlemen, that's the absolute worst line I've ever made in my entire life. That's alright. It's the thought that counts. Except for in math when you actually need to be accurate. We all know how to graph. You could use your calculator to check. Speaking of calculator, the table shows how much a carbon blah, 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 blah. Oh, is it linear? Explain your answer. All right, time for explaining. As Ricky Ricardo said, Lucy, you have some splaining to do. Ricky Ricardo, rest in peace. So I have to find the pattern, just like the guy at the very top. So that's plus 1, that's plus 15, that's plus 20, and that's plus 20. So this is not linear. The question is this relationship linear? No, and the reason why it's not linear is because the pattern of y over x changed. 15 over 1 is not the same as 20. So if I wanted to say that, 15 over 1 is not 20 over 1. That's just me going one step further. So this tells me that this is not linear. Praise the Lord, we are done. So after all that, you're going to get 100 on this test. This video is going to end up being like 1 trillion minutes long, so I'm sure you're going to watch it several times. Bye!